chlorine is used to decrease the number of microorganisms in water. When chlorine is added to water, there is a redox reaction as shown by the equation. Deduce the oxidation states of chlorine in HClO and in HCl. So HClO, remembering that, let's have a look at that. Let's just get rid of that line that's happened. If we think about HClO, H is +1 always, and oxygen is -1, and the whole compound adds up to nothing. So the Cl must also be +1. Whereas if we look at HCl, if H is +1 and it adds up to nothing, then the Cl must be -1 in this case. Remembering that in the element it's 0, so it's gone from 0 to +1 and 0 to -1. Now it says give two half equations, so we're going to use the rules for half equations to do this. It wants the oxidation half equation, and that would be where the number goes up. So that means we're starting from Cl2, we're going to the one where the number had gone up, and the number went up to HClO, it was +1, and in reduction the number is reduced, so we would be going from Cl2 to HCl. And then we're going to use the rules on each of these. So rule number 1 says balance the element undergoing redox. So there's 2 chlorines, so we're going to put 2 in front of HClO so that there's 2 chlorines on each side. Now we add water to balance the oxygens. So we've got 2 oxygens on the right. We're going to add 2 oxygens to the left by adding 2 waters. And now we add acid, protons, H+, to balance the hydrogens. At the moment we've got 4 H's on the left and 2 already on the right, so we need 2 more. And then we're going to balance the charge by adding electrons. There's 2+ on the right and nothing on the left, so we need 2 electrons. We're going to repeat that process here. We need to balance the chlorines first. There's no oxygens, so we don't need to add water, but we will need to add acid to balance the hydrogen ions with the hydrogen. And then we balance the charge with electrons. So we've written 2 half equations. The next question is just a memory thing. It says chlorine is reacted with sodium hydroxide. So it's a test of formula. You then do need to know that it makes sodium chloride, sodium chlorate 1, and water. And then you need to balance that equation. And to balance that equation, you just need a 2 in front of sodium hydroxide. We're then going on to a moles question from there. So the concentration of ClO- ions in bleach can be found by reaction with iodide ions. Okay, so iodide ions being here. So a sample of bleach was found to contain ClO- ions with a concentration of 0.0109, and the potassium iodide is added to 20 centimetres cubed of this bleach. So all these numbers in the yellow are all to do with the bleach. It says calculate the mass in milligrams of the potassium iodide needed to react. So let's start with what we've got. We can do the moles of the chlorate ions because we've got a volume and a concentration. So we're going to go moles are very clever, volume times concentration. The volume is 20, but notice centimetres cubed and the concentrations are in per decimetre cubed. Let's convert centimetres cubed to decimetres cubed and then use our calculator to find out what that is. And we're getting 2.18 times times 10 to the -4 moles. Now we want to relate that to the moles of I-, and so we're going to need to use the ratio. And according to the balanced equation, for every 1 chlorate there are 2 I-, and so the number of moles of I- would be 2 times this number. So it should still be on your calculator screen. You can just press times 2 and equals, and you'll get 4.36 times 10 to the -4 moles. So our new moles. And then you can answer the question, which is mass but we do want the mass of potassium iodide. Mass is Mr. Moles, so we're going to add up potassium iodide. And if you add up potassium and iodine, you're going to get 166. And you're going to times that by the moles. And you're getting 0.0724 grams. An appropriate number of significant figures here is 3 significant figures. But the answer wants it in milligrams, so then you're going to times by 1,000 on your calculator to find out it's 72.4 milligrams to 3 significant figures. And it says, what would you observe during this reaction? So you are adding chlorate, which is a colourless solution, to iodide, which is also colourless, but you're forming iodine in solution, and iodine is brown. So we would observe a brown solution depending on the amount of water present. You might get a bit of iodine black solid, but brown solution is what we're looking for. And then the final part of the question says potassium chlorate 7, so it's a different chlorate, it is used in fireworks. When it decomposes, so potassium chlorate 7, which they've given us the equation for, the formula for, decomposes. It decomposes means turns into, without any other, heated it up to break it down. Potassium chloride, we're supposed to know. Oxygen, we're supposed to know. And then we just need to balance this. So we put a 2 in front of the O2. And then it says use the data in the table. This is all formation, which means from its elements in their standard states. The enthalpy change when 1 mole of KClO4 is formed from its elements, K, half a Cl2 and 2 O2s in their standard states, takes minus 434 kilojoules to form KClO. And then to form KCl from a K and a half a Cl2 makes minus 436. This conversion is 0. By definition, the element hasn't changed. Okay, so all we need to do is, if we want to work out our x across the top, we need to use Hess's law and find an alternate route from the start to the end of our cycle. So this is our start point. X goes from the start to the end the quickest way, but what does the other route go? So x equals, we're going against the arrow, so it becomes plus 434, but then we're following the minus 436 arrow. If we add that up on our calculator, we're going to get minus 2. So we need to write our answer here, minus 2.